6.5 Trapezoidal Rule. So is there a better way to approximate the area under a curve? Now, definitely yes. I mean, those squares leave so much to be desired. So they said, hey, what if we made a trapezoid? Now, here's the question you should be asking. Who cares? Why are you coming up with another way? We know how to do this precisely. Well, as you may or may not have noticed, we're not really good at doing integrals. They can be kind of tricky. So we decided to go with this and just use it to approximate. It's the best way to approximate. Sometimes you don't have access to high-powered calculators, and you're just going to approximate with a trapezoidal approximation. While I'm here, let's go crazy. Base naught, base 1, base 2, base 3, base 4, ... Height, all the same. These are different. These are all the same. It's not height 1, that's just height, ... So the area of a trapezoid, you may remember, you might not. If this is base naught and this is base 1 is the h, it's the average of the bases. Wait a minute, standing up, how can they be bases? Yeah, well, deal with it. Times the height. The next one would be 1/2 b1 plus b2 times the height, plus 1/2 b2 plus b3 times the height, plus ... We can factor out the half and factor out the h and throw them out front. Throw them out front. We only get one b naught. We get two b1s, two b2s, two b3s, two b4s, until we get to the very end. The b last, there's only one of those. We throw it in with y's, y naught, yn, everything else gets multiplied by 2. That's a nice shortcut. I don't recommend it early on because you're just gonna make a mistake from getting confused. More to the point, you're not always gonna have the same height and it gets a little weird. So I like to write it out and then make generalizations just like I did up here. That's just me. Notice, by the way, that the h's is the distance, b minus a, over how many partitions to n. We're kind of looking at a Riemann sum thing here. I like to compliment myself right now. All my h's actually look like h's so far. Usually they look like n's, so I'm pretty proud of that. All right, by the way, a lot of people notice this much later. Trabzoidal rule. Here it is there. And by the way, this means nothing until I give you an example. It's like averaging LRAM plus RRAM, if you think about it. How do you find the average of something? Add them together and divide by 2. So yeah, left, right, area. I don't remember. Left, right, area, midpoint. Yeah, whatever. So Riemann sums using left and right endpoints. It's not R for Riemann, it's left, right, area, method. I'm on a roll today. By the way, this is a pretty sweet lesson. So use the Trapezoidal rule with n equals 4 to estimate. Yeah, I'm not gonna use int. I can do this by hand. That's ludicrous. But I gotta draw up big. X squared, zoom 4, 2 and 0, 1, 1/2, 3/2, 1, 2, 3, 4/2. Might need this point. 1/2, comma, 1/4, 1, comma 1, 3/2, comma 9/4, 2, comma 4. Like I said, I might need those points. We'll see. All right, let's do this long way and then the short way. Long way. Each one. Area is 1/2 the height. Height's always 1/2. base 0, notice the base of the y value, plus 1/4, plus 1/2 the height, 1/4 plus 1, plus 1/2 the height, 1 plus 9/4, plus 1/2 the height, 9/4 plus 4. I'm not even going to try and do this. I'm going to factor out that. So that's 1/4. 1/4 plus 1/4 is 1/2. Plus 1 is 1.5. 2.5 plus 4, 6.5. Also known as 13/2. Plus 9/4. That's 2/2. 26 plus 9. 26, 35 over 4. 1/4 times 35 over 4 is 35/16. And that's a little bit more than 2. It's 2 3/16. Got the calculator divided over here. 2.1875. Yes, I know I went more than 3 decimal places because I'm being precise. Notice that if we did this with their little rule, we'd get A equals 1/2 times, actually I don't have to write that, times 1/2. Yeah. And then it would be 0 plus 2 times 1/4 plus 2 times 1 plus 2 times 9/4 plus 2 times, no, just plus 2. Where'd it go? 9/4 plus 4. And that gets me the same thing. Let's check, see if we get the same thing. 1 divided by 4 times 2 times 1/4 plus 2 plus 2 times 9/4 plus 4. 44. I went 1 times 4. I think it's best to just do this. Divided by 4. 2.75. Something is wrong. Oh, I went from 0 to 2. Naughty, naughty, naughty. Let's just change the problem then. 0 to 2. So one of these is wrong. I'm going to assume this is wrong in red. I don't feel like going over it for half an hour. What should I? 9/4 and 4, 1 and 9/4. 2 times 1/4, 2 times 1, 1/4. 1/4, 1/4, 1, 1, 9/4, 9/4, 4. It's 4. Check my work real quick. 1/2, 1/2. Yeah, I'm guessing 2.75 is right. Well, let's go and do it legit and see which one it is. Notice, if I had a guess, it'd be this one. We'll find out in a second. I'm sure I made a mistake up here. Notice what a mess it was. This is a lot more straightforward. If you need to, do it the long way and then go from there. So area equals x to the third over 3 from 0 to 2, which is 8/3, which is 2.667. So I'm betting this is right. It looks like I made a mistake here. Let's see if I can find it real quick. 1/4 plus 1/4 is 1/2. Plus 2. 5/2 plus 4. Oh, that's 13/2. Oh, there's 2 9/4. Naughty, naughty, naughty. So that'd be 18/4. And 18 plus 26 would be 44. 44 2.75. There it is. All right. Oh, I actually wish I'd done that on purpose, but I didn't. I was just being stupid. To show you, really, you can do it the long way, but yeah, you've got chances to make mistakes. This is a much easier way to do it. And then, of course, I say to use int. So math 9, 0 to 2, x squared, 2.667. So yeah, lots of ways to get it done. Cannot possibly overstate what I'm about to state. And I know you're all smarter than me and that I'm just an idiot and that, you know, so on and so on. You gotta graph these. You gotta graph these. If for no other reason to figure out what your X and what your Y is. Well, that was really horrible. Noon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, midnight. What is the average temperature? Well, we can find the area, but we're gonna have to do that 1/12 thing because it's an average temperature. So as low as 55, let's go with 50, as high as 70, 60, 70. Now, when I say you have to graph it, that's just me. And really strong recommend it. 66, 60. Oops. That dot a little bigger. 70, 69, 68, 68. Okay, way too far down. That's okay. And then trapezoids up, over, down, up, over, down. I'm not going to do them all. Dot, dot, dot. All right. But now I look at it and I say, okay, I understand what I'm doing. First off, average temperature, RTFQ, read the full question. 1/12. That's 1, 2, 3, 4, 5, 6, 7, 8, 12 gaps from noon to there. Times 1/2 times 1. That's the width of each gap. 63 plus 2 times 65. Wait a minute. It's 2 times all of these. Plus 66 plus 68 plus 70 plus 69 plus 68 plus 68 plus 65 plus 64 plus 62 plus 58 plus 55. There's 2 times all those in the middle. All right, I factored it out. This is the shortcut that you can do. Plus it out. And here's the fun part about this. Yes, you can make mistakes, but if you get 128, that's clearly not the average temperature. Knock this out and I get 65.167 degrees. Temperature, they didn't say temperature, I'm gonna go with Fahrenheit, but we don't know for sure. That's it, we're done. All right, neat little system. Like everything else, it takes practice. So don't just, oh yeah, I can do this. It's not gonna work. Good luck and happy